Alrighty, we're going to go ahead and get started. It's so nice to see all of you and your hellos from everywhere, all over the world, over in chat. I really want to thank you guys for joining us today for our message-driven microservices and monoliths with Micronaut webinar. I'm Jen, and I work with the 2GM team here at Object Computing, and we're happy to have our guest presenter, Oracle developer advocate Todd Sharp, presenting to you today. From Object Computing, we also have joining us Jim Cassidy, who's one of our solution architects that is part of our cloud practice, and he'll be available to help field some questions if you have any of those. As a reminder, please do load up your questions into the Q&A section of the application, and we will do a live Q&A session at the end and answer as many of those questions as time allows. We are recording this session and we'll plan to make it available to view on demand after. Todd is going to go ahead and show us a few tricks for simplifying communication between distributed services by combining a Micronaut framework with some popular messaging solutions. So Todd, I will go ahead and turn it over to you to get started.
Thanks, Jen. So I just want to put it out there really quick that yes, I picked that title just to be very difficult to pronounce and to hear Jen try to say that alliteration. Jokes aside, message-driven microservices and monoliths with Micronaut. That's the title of the session today. As Jen said, very cool to see folks from all over the globe joining us today. I appreciate you taking your time to be here. I promise you that we're going to have a fun session, hopefully. And as Jen said, ask questions. If you have any questions, put them in the chat and I'll be glad to address them, and Jim will help out with those as well. So as Jen said, I'm a developer advocate at Oracle, and I've been around the block for a little while here, working in Java, Groovy, Grails, Cold Fusion, all those kind of awesome things for the last 17 years. And here's my promise to you today. In the next 60 minutes, you're going to learn how to use messaging to communicate between distributed services using, as Jen said, some popular tools, some popular frameworks, and of course, the Micronaut framework. That's why we're here today. I don't want to take a whole lot of time talking about kind of fluff and background and why today, because I hope you all kind of understand the why as to what we're talking about here. We're going to talk about, we're going to look at some scenarios using a basic e-commerce type workflow. And I know it's simple and trite and kind of contrived almost, but I think that it illustrates, I think it is a good example of why you need messaging, right? You think about a typical e-commerce type system, Amazon, whatever you might be thinking of. And you think about the way the business logic and the flow of the application, right? An order is placed into the system by a consumer, by an end user, and the order needs to be shipped by another service, most likely, right? Of course, there's some billing and some things that I'm leaving out, some validation, verification, those kind of things. But essentially, we're talking about order placed, order shipped, order updated. Right? Because what good is shipping an order and charging the customer if you don't then give them that feedback that their order's been placed or received or shipped or these kind of things, right? So that's the basic flow that we're going to look at today. Now, as I said, services need to talk, correct? I mean, if you think about it, it doesn't matter if you fully embraced microservices from like a complete standpoint. If you've got 200 different microservices, it doesn't matter if you've done that, or if you're kind of on the other end of the spectrum and you just have a few different types of distributed services, whatever label you want to put on that, that's fine. It doesn't bother me. But the point is, most applications, even the very simple ones, and I don't mean simple as in to trivialize or minimize their importance, but even the very basic applications usually have more than one service on more than one server. And of course, they need to talk, right? Usually they need to communicate with one another. Now, traditionally, how did we do that? Well, traditionally, back in the old days, and I could say that because I've been developing since 2004, and back in the old days, if we had distributed services, we would make them talk to one another directly, right? Via HTTP, via REST, something like that. And I compare that to the old tin can string method, right? You've got a direct line of communication between the two services, and you send a REST request to let's say the shipping service, and you receive a response, so on and so forth. Now that all worked, it's fine. And for the very basic of things, that still works today, right? But what happens when that string gets cut? What happens when that line of communication gets broken? If your order service talks directly to your shipping service and the shipping service goes down, you're in a big whole lot of trouble, right? Your order service is now receiving orders and they're just piling up and they're not shipping. Even worse, maybe you don't have the proper system put in place and you think they're shipping. And of course, nobody would do this, right? But worst comes to worst is you've got a whole lot of orders that have been placed that haven't shipped, and you need to now deal with that. And of course, you could put in some retry logic. You can put in some queuing, manual queuing, right, on the order side, but you're managing all that yourself right now. You're increasing complexity. You don't scale very well, first of all, and you're increasing the complexity of your architecture, your system, more points of failure, and that's not fun for anybody, right? We're talking about game over. That's a bad thing. It's a bad situation to be in. So, like this lady says, what do we do now? Well, the solution here is to introduce messaging into the equation. And that's where we're going to start getting into the demos. And really, now that hopefully I've laid out the reason why we want to do this and the reason why messaging is good, we're going to get into the how to do this, right? So typically, in a message-driven type world, your order service would produce messages to a message broker, and your shipping service would consume messages from that message broker and also possibly produce its own messages, which are then consumed by the order service. So let's see what this actually looks like in practice. We're going to start out with Kafka, and Kafka is a very popular solution for messaging. It originated, I believe, with some engineers in LinkedIn, if I'm not mistaken, were the original creators of Kafka. And I'm not going to go deep dive on Kafka. Just understand that Kafka is a messaging broker. If you want to learn more about Kafka, there's tons of resources you could use. But we're going to look at using Kafka as a message broker for our first example here. So the first thing we're going to do is download it, unzip it, start up something called Zookeeper. And Zookeeper is a dependency that Kafka has that basically is a configuration manager. It's kind of a meta storage point for all the configuration in Kafka, all the broker information and so on and so forth is stored in Kafka. And the broker itself needs to be started after that. So let's do that really quickly. Let's start up Zookeeper first of all. And I've got some aliases here that are going to help me do that. So Zookeeper is going to start up here. And it looks like it's started up. We're going to start up a Kafka broker in another tab. And just as soon as that gets going, looks like that's good to go. We are up and running. So now Zookeeper and Kafka are up and running. The next step here is to create a topic. And a topic is just a channel that Kafka listens on for messages as they kind of get passed back and forth. So we're going to create a quick test topic, and then we're going to use what's called a consumer and producer to talk on that channel. So I've got my shortcut here, and I should point out here that when you download Kafka and you unzip it, inside the binary directory within the directory that you unzip to, there's a series of scripts, and those scripts are what I'm using right now to start, stop, create, all these kind of things. More information on this. In fact, I should have mentioned this earlier. I have a series of 4 blog posts that go over this whole process in detail. So if you missed something, if you want a little more detail, there's links at the end of this slideshow to show you all those blog posts so we can go back in detail and look at all those. But suffice to say that there's some scripts in the binary directory. And this one I'm going to use is to create a topic. And we've created our topic, test topic. You see, we got a feedback here to that extent. So now we can test this right from our console. We can create a consumer and a producer right here in our console. And we've got a consumer going here. And let me just open up one more tab. And oops, go back to my directory, source the shortcuts file. All right, clear that. So now test producer. All right. So in this tab here, we have a consumer, and in this tab, we have a producer, and this is on the test topic. So you can see now if I go into my producer and I type a message and I hit enter, you can see that that message gets received in my consumer. Really easy, really quickly got messaging already done, and I'm testing it from the command line. So really nice, really easy, really quick. Let's cancel out of those. And let's, just for our demos, let's create our order topic. And all right, so create our order topic and create our shipping topic. And we are going to use these in our demo. So I'm just creating two topics to be used for orders and shipping. All right, so those two topics are created. Very cool, good to go. Let's now go back to our slides and let's get into our demo of orders and shipments. So what I'm going to do here is I have two microservices created already with Micronaut. They're very basic applications. I've created them already, and I'm going to show you what those look like here in IntelliJ. And we're going to enhance these services to add messaging. So very quick look at what it looks like. I have a couple of domain objects here. This domain object represents an order into our e-commerce system. It has an ID, a customer ID, a cost, and a shipment status. And shipment status is just an enum. I have shipment status pending and shipped. So I have just this very basic order service. And inside of my order service, we are just using a list for persistence. I'm not going to actually use a database here, but of course, you could plug in Micronaut data. You could use whatever persistence framework makes you happy to do actual persistence. But for this purposes, I'm just going to use a list and just store the orders in memory. So I have a list orders method, an update orders method, and a new order method in my service. My controller just has some endpoints that use this service for basic persistence modeling, right? So I have this new order method, and it just adds an order to our list inside of this service, and it sets the ID to the next number based on the current index of the list. So very basic, very simple service for orders. Now, if I run this service right now, it's really nothing fancy, but just to show you that it works, I want to show you really quickly that once it gets started, of course, every time I get Zoom and everything else going, it kind of slows down my launching of new applications here in IntelliJ. We'll give it just a second and it should catch up with us. All right, excellent. So it's up and running, and you can see here that we can hit the localhost 8080/order endpoint with a post. And if we post this JSON object, you can see that we get a response and the order is in shipment status pending when we place a new order. So very basic, very simple, nothing crazy, nothing fancy going on here. Now let's get into the actual messaging part of this demo, and let's go to the terminal and let's actually create our producer, because we want our order service to start producing messages. Let the produce messages so that later on our shipment service can consume those and it can know when new orders have been placed. So what we want to do here is we want to create an order producer, and we can do that with the Micronaut CLI. And this Micronaut CLI, when we have that installed, gives us a create Kafka producer command, and we just tell it the fully qualified name of our producer, and we run that. And if we come up to our project, we can see that our order producer was created. Now, this is just a very basic interface named order producer. The only thing we can see here different than a normal interface is that it's annotated with @Kafka client. Now, the really nice thing that Micronaut gives us when it comes to working with Kafka and messaging in general is that this interface the only thing we have to do at this point is create an actual method signature called send message and annotate that with the actual topic in our Kafka queue. And at compile time, Micronaut is going to say, okay, well, I know that I need to create a producer to produce messages on the order topic, and it's going to wire up all of that for us at compile time. We don't have to worry about implementing this interface on our own. And at runtime, we'll have a order producer class available for us with a send message method that expects a key and an order to be produced on our topic. The other nice thing here is you can see that I'm using a domain object, a POJO, a class called order, and Micronaut's going to be smart enough to serialize that as JSON, and we don't have to worry about any of that ourselves. So if we come over to our order service at this point, and we come up here, we can, as I said, now inject this into our order service and come down to our new order method. And when our new orders are placed, we produce a message to our order producer that contains the contents of the order, right? So now when we run this, in fact, let's rerun that really quickly. And if I come over to my terminal and I start an order consumer in my terminal, so as I said earlier, as we looked at earlier, the order consumer is just a very simple consumer in our bash shell that we can use to listen for messages. And I place an order or two, and I come back to our consumer. We can see that we're now producing messages on our order topic. So the next step is obviously logically going to be to consume those messages from our shipping service. Let me shut down that consumer, and let me shut down the order service. And at this point, we're going to hop over to the shipping service and start listening for messages in our shipping service. I didn't mention this earlier. I should have, please forgive me. But really the only configuration that we need to do here in our application is tell Micronaut where the Kafka server is. And that is done inside of our application configuration file. And we just point it to the actual location of the Kafka broker, and we're good to go. So at this point, now inside of our shipping service, again, we have our same model inside of our domain directory, our domain package. We just have the same objects because they're going to be reused on this side of things. The only difference here is a shipping service, and the shipping service, again, uses a list for in-memory persistence, if you will, mock persistence. And we're going to use a synchronized list here just because if we get multiple messages coming in at the same time, we want to be able to handle that in a thread-safe manner. So the only thing we have here that we really need to look at right now is a new shipment method. And that is basically how we create new shipments for our shipment service. So again, we need to start listening in the shipping service for new orders to come in on the wire. And we do that with the create Kafka listener command from the Micronaut CLI. So if we run that command and we come up here, we can see that a order consumer has been created, scaffolded out for us here. Here we have the Kafka listener annotation, and inside of our consumer, we can start building that out. First thing I'm going to do here inside of my order consumer is inside of my constructor, I'm going to inject the shipping service. And that way, when we receive new orders inside of our order consumer, we can create new shipments by calling the shipment service. Next step here is to add a single method, again, annotated with @topic and the given topic. And this one uses RxJava. And here we have a receive method, and we receive an order flowable object into the receive method every time an order is consumed, an order message is consumed. Excuse me. And inside of that order flowable, we're going to return order flowable.do on success. And this is where the magic is going to actually happen here, right? So inside of our consumer here, every time we receive a message, we're going to do some basic logging. We're going to simulate some slow shipping, and we're going to create an actual shipment via the shipping service new shipment method. So if we now run this guy, we come back over to our order service and we run this guy, we should have a basic system in place for orders being placed, messages being produced, messages being consumed, and shipments being created on the shipment service. So let me come back to my order service, see if it's running. Not quite running yet. The shipment service is running. So in just a second, when the order service gets running. All right, excellent. So order service is running. We can come back over here and start placing orders again. And if we place a few orders here, we can see inside of our shipping service that our shipping service is receiving orders and creating shipments. Awesome, exactly what we wanted to do, and really nice and handy. Now, what happens though, if our shipping service goes down and our order service is still up and running and it's still receiving orders, and we've placed a bunch of orders now, and we come back over here, make sure, let's start our, actually, let me come to the order service. So as I said, order service is receiving all these new orders. Everything is happening just as we want it to, and our shipping service is down though. Maybe we're doing a build, maybe there's some maintenance happening, whatever it is. Obviously, when we start this up, we should exactly expect to happen is happening. All of our orders are being consumed and shipments are being created. Just because our shipment service is offline does not mean that our shipping service cannot still do its thing when it needs to do its thing when it gets back up and running. So let's quickly come back over here and let's start also telling our order service that we've now created shipments, and it can so that it can update the shipping status of the orders when after we've shipped an item, because obviously there's no good in creating shipments if we're not closing that loop and telling our order service that we've now shipped our items. So if we come to our shipment producer, we can again create a message, send message signature. And this time we're going to use the shipping topic. And if we come over to our shipping service, once we've, oh, actually we need to inject that shipment producer into the shipment shipping service. And then we come down here and start producing messages back on the shipping topic. And if we come over to the order service, we can create our shipment consumer. And just like we did on the order consumer, we can handle that as necessary in the shipment consumer. So the shipment consumer also has a receive, and inside of that, we're going to receive another flowable. And we're going to, this time, get the order by ID of the incoming shipment order ID, set the status to shipped, and then update the order. So if we restart this, and we restart the shipping service, what we're going to expect to happen at this point now is when we place an order, the order is going to produce a message on the order queue. The shipment service is going to consume that, create a shipment, create its own message back to the shipping topic. The shipping topic is going to be consumed again by the order service. The order service is going to update the shipping status to shipped instead of pending. So if we place an order, first of all, we can see that the shipment status is pending. And if we get that order, give it after just a few seconds, we can see that is now shipped because our order service has consumed the shipping message and it has updated its shipping status to complete that loop, complete that feedback, right? Now, let's head back to the slides and let's talk about messaging in the cloud. So this is all really great. This is all handy and helpful that we've created this using a local Kafka broker. But what happens when we want to deploy or build our applications up to the cloud? Of course, we're going to want to use some sort of cloud-based service to handle this for us. You can technically spin up some VMs and manage your own Kafka broker up in the cloud. Nobody really wants to do that. You're talking about expenses, you're talking about maintenance and all of that other stuff that nobody really wants to mess with. So at this point, usually we're turning to managed services. And since I'm an Oracle developer advocate, we're going to talk about the Oracle streaming service. Now, if you don't use Oracle Cloud, first of all, why not? Second of all, most cloud vendors have some sort of Kafka compatible service that they offer. I know AWS does. I'm pretty sure Google does. I'm sure Azure must as well. But usually these are either like Kafka managed services or they're a homegrown service for messaging or streaming. And in the case of Oracle streaming service, and I'm sure the case of others, usually they are fully Kafka compatible, right? So the nice thing here is Oracle streaming service, we have to do is basically create a stream, and we do that in the Oracle console dashboard. You could do it through the CLI, you could do it however you need to do it. But you create this stream, and a stream is basically analogous to a topic in the Kafka broker. You create a user group policy, all that fun stuff. And I do have a blog post about this as well, if you're interested. And then you create this configuration variable called Kafka Sazzle Jas config. And what that is a simple string that is constructed that tells Kafka what it needs to know in order to connect up to this particular broker. In our case, oops, let me go back. Didn't mean to click that many times. So in our case, we use our tenancy name, a username, our stream pool, OCID, and then an auth token as our password. So again, I do have a full blog post on this, but in order to demonstrate this, I want to show you, switch to this other run configuration and run that. And then switch to this, stop that, switch to that configuration and run that. So if I come back to my order service and I look at my application OSS, so the only changes that are required at this point is our configuration. So we tell it the Bootstrap server to use, in this case, our Oracle Cloud streaming service server with the same 9092 port. We tell it the security protocol, and then we pass in that string that we constructed containing all of our credentials. And if we check things out here, it looks like both of them are up and running. So if we come over here and we place a few orders, oops, oh, that's why. Sorry, place an order. All right, so place a few orders here. And what I want to show you now is, this is the Oracle Cloud dashboard. And you can see back in our shipping service, everything is working just as it did before. Orders are being placed, messages are being sent, received, shipping statuses are going to be updated. In fact, let's confirm that. Yes, this order has now been shipped. So everything is working just as it did with our local Kafka broker. But this time, we're actually sending messages to this order topic in the Oracle Cloud. And you can see that by loading the recent messages here. And this one just at 16:31, so just 30 seconds ago, this is a message that we received. So if we hop over to our shipping topic, you'll see again the same thing. If we load our recent messages, all of those shipping messages are available for us to see. So the only change we did was configuration. We had to do a little bit of work up front to create a user, create some policies, things like that. But we plugged that configuration into our same application. The only thing we changed was the configuration. Didn't have to change anything at all inside of our code, and everything works just the same as it did before. Very cool and a huge win in my book. Let's head back to the slides, and I just demoed that. So at this point, the only thing left I'd like to talk to you about is using RabbitMQ. Now, I hate to admit this, but I am not an expert, and I know somebody's going to ask the question, what's the difference between Kafka and RabbitMQ? And I have tried to research this question many times myself, and I've never really come up with a great answer. From my own personal experience and my own personal opinion, I can give you that. And in my own personal opinion, the difference is Kafka seems to me to be a more enterprise type solution, a more secure type solution, a more scalable, large scale type solution, where if I was building an application for a client, an enterprise client especially, and I needed to do some messaging, I would reach to Kafka. Now, RabbitMQ is something that I use quite often when I'm talking about doing little projects like IoT and things like that, where I need to do some simple messaging, get some message from a IoT device and publish it up to the cloud, and then consume that maybe from a cloud-based, cloud-deployed application or a mobile app or something like that. So I use it for smaller scale type things. That's not to say it can't handle large scale type things. I've not tested it on a large scale, but I say all that to basically point out that Micronaut has a really nice bit of support for RabbitMQ as well. And I want to show you, I'm not going to show you any code actually running, but I will show you that we can do the same basic premise with RabbitMQ that we did with Kafka. And let me just shut down these services that I already had running, because we're going to reuse those ports in just a second. So order service, shut that down. Okay. So before we do that, I want to show you that there's a little bit of process that we need to do to set things up here on this side of things. Now, with the Kafka, we had the create topic shell script in our bin directory that we use to create our topics. With RabbitMQ, what we need to do is a couple steps. We need to create what's called a queue. And so what I'm creating here is an order queue and a shipping queue. And then we need to create what's called an exchange. And then we need to bind the exchange to the queues. So just some couple screenshots here showing you how to do that. And once we get to that point, we create our producers and consumers, our publishers and listeners, wherever you want to call them, via very similar commands. And these are the commands that you use: create RabbitMQ producer and create RabbitMQ listener. And again, just pass the fully qualified path to where you want that to produce. And when we get that far, we can look at the application itself. And if I hop over to the order service RabbitMQ, the change in configuration is right here. And in this case, we have our URI for our RabbitMQ exchange, our server, our username, and our password. Now, I do want to show you here that I'm actually, I'll get to that in just a second. So we'll forget that. So what you see here is our RabbitMQ username, password, and URI. I don't. Why IntelliJ are you not expanding that? Okay, let's do this. So if we look at our order, I mean, it's exactly the same thing. I just basically copied and pasted all of the code into this order service RabbitMQ. The order producer here, if we look at that, the difference being here is this time we have a Rabbit client annotation on the interface. We pass it the exchange name, and then we create a binding using the @binding annotation, and we tell it the queue that we want to bind to. So just like we had Kafka brokers and topics, on the Rabbit side, we have Rabbit clients and bindings. So same premise, I think, but just language is a little bit different. And we use a send order signature on that. And if we have a shipment consumer, so if we look at here, we have @Rabbit listener instead of Kafka listener. We tell it the executor that we want to use, and I'll get back to that in just a second here. But instead of @topic here on the listener side, we have @queue. And other than that, everything is essentially the same, just a little bit of different language here. But if we now run our order service and come to our shipping service, RabbitMQ, again, we have the same configuration over here. And take a look at this service. Same thing. I mean, basically shipment producer here, and our order consumer is a Rabbit listener, and our shipment producer is a Rabbit client. So same thing on this side, on the shipment side. We start that up. All right, looks like our order service is up and running, and you can see a little logging information here that it retrieved the channel, an AMQ channel from our RabbitMQ server from the pool. So it gives you a little debugging information there. And give the RabbitMQ shipping service 1 second to start up here. All right, excellent. So that's up and running. Come back over here and we place our orders. And we retrieve our orders, still pending, and now it's shipped. So same concept. It works exactly the same as our Kafka example did, but for whatever reason, if you want to use RabbitMQ with your Micronaut application, it's going to work very similarly. It's going to be just as easy as it was to use Kafka. And I do want to point out here a little note here about threading. So in my examples, as I was building out these demos, I noticed you had to kind of do a little bit of playing. And I don't know that this is not a bug. I need to look into this a little more and talk to some of the engineers. I don't know that this is a bug or not, but with a RabbitMQ listener, it will not use multi-threaded consumers unless you specify the actual executor. So if you see down here, I have executor equals consumer, and that represents this consumer. I thought consumer was supposed to be default, but in my testing, it didn't work that way. And it didn't use a multi-threaded consumer until I specified that in the Rabbit listener. So with Kafka, your consumer is going to be multi-threaded unless you specify a small number of threads that basically prevents it from being multi-threaded. Now, this is a huge deal to you depending on how you want to consume your messages. If you If you want to consume your messages in the order in which they were received in block until the order processing is complete, then obviously you don't want it multi-threaded. If you want to be able to handle as many at the same time as possible, then you do want it to be multi-threaded. Now, certainly this matters if you have things being done to an order, let's say after the order was created. If that matters to you, if the order matters, then this is going to be something you need to pay attention to. But if not, then multi-thread it and you'll have great performance in your application. And essentially, finishing a little early here today, but essentially that is the entire presentation. I think it's a simple, it's of course a testament to Micronaut as to how easy the framework makes working with messaging queues. As I said, everything is handled at compile time. When it comes to your consumers, all of that hard work to implement those classes is done behind the scenes. The only thing you need to do is specify the method signature in your interface. And when it comes to consumers, it's a basic class with a signature. Now, there's a lot more to all of this, and I do encourage you to check out the documentation. If you, again, when it comes to multi-threading, when it comes to the various method signatures, how you want, if you want the timestamps on the incoming messages, all of these things, very powerful. You can get as in-depth as you want to. When it comes to your producers and consumers, just check the docs and take a look at those depending on your situation. Excuse me. Again, I appreciate your time. Thank you for joining me from wherever you are in the world. Of course, we're open to questions here. I encourage you to check out my blog posts if you want to read more about this. Code repos for all of these examples that we looked at are up on GitHub under my Recursive Codes account. And here's my contact information if you'd like to talk more. If we don't know each other, please introduce yourself, let me know. And again, appreciate your time.
Yep, thanks guys. And please make sure if you haven't already to tune in Thursday, the 25th. We have another webinar coming up with our friends from Novatech and Camunda talking about their Micronaut integration into their project. So we look forward to seeing everyone on our next webinar. Thank you.